In this lesson, we're going to go over function graphs. Specifically, we'll understand the input and output of a function, we'll identify domain and range of a function given a graph and learn to write that in interval notation, and then we'll identify intervals where a function is increasing, decreasing, or constant. First, a little bit about functions. The formal definition of a function is given a relation, x and y, we can say y is a function of f if for each element in the domain, x, there is exactly one element in the range, y. Okay, so a little bit about notation. Before, or graphing lines, we saw y equals 3x plus 2, and now we're seeing f of x equals 3x plus 2. So if you watched the previous video on domain, this is a little bit of a review, but f is the name of the function. It's what it's called. X are your input, so you put in an x value, and then what you get out is when you evaluate that. Okay, and this would be your output. So for instance, with this function, if I wanted to find, let's say, f of 3, 3 is my input, so I put in 3 everywhere I see an x. F of 3 equals 9 plus 2. F of 3 equals 11. So 3 is my input, 11 is my output. Okay. Or another way to think of it is like your input is your x and your output is your y value, which might come in handy when we're looking at graphs. Okay, so example 1, inputs and outputs of a function. So if we have f of x is equal to negative 2x squared plus 4, if we're finding f of 3, that means we're going to plug in a 3 everywhere we see an x in the function. So we have f of 3 is equal to negative 2 times 3 squared plus 4. To evaluate this function, make sure you use order of operations. So this would be negative 2 times 9 plus 4, which is negative 18, plus 4, which is negative 12. So what we just found is that f of 3 is equal to negative 12. Now sometimes your inputs aren't always numbers. Sometimes, like in example B, they could be numbers or variables. In this case, we'd be plugging 3x to every x that we see in the function. So what this looks like is f of 3x is equal to negative 2 times 3x squared plus 4, and then you evaluate or simplify based on order of operations. So this is negative 2, 3x squared is 9x squared, and this becomes negative 18x squared plus 4. Okay, so you input 3x, you got out negative 18x squared plus 4. Let's apply inputs and outputs to graphs of functions. Let me see if I can zoom this in. So the graph of the function f, the name of the function, is shown below. Find f of negative 1. From function notation, negative 1 is an input or an x value. So with these problems, if you're given an input, it's typically asking you for the output or vice versa. So we find where x is negative 1 and we look at the corresponding y value. That y value is 0. Okay. So f of negative 1 is 0. Let me see if we can do another one. Let's say we were asked to find f of 2. So we go to where x equals 2 and go to the function. The y value there is 6. So f of 2 would be 6. For the next one, the graph of g is shown below. Find one value for which g of x equals negative 1 and find g of 1. So for the first part, x is our input, that's the piece that's missing, but the y value is negative 1. So if we go y is negative 1, and then we go to the function, either direction, x could be negative 2 or positive 2, which is why the instructions say find one value of x for which g of x equals negative 1. Okay. To find g of negative 1, this is our x value, or to find g of 1, 1 is our x value, so we're looking for a corresponding y value. So you go to x equals 1, go to the function, y equals 2. Okay. Domain and range. So the set of x values of a function is called the domain, and when you're looking at the values, you write or read them from left to right or smallest to biggest. The set of y values is called the range, and again, you read those values, oops, there's a typo there, smallest to biggest or bottom to top. So when you're given a graph, you'll be asked to write the domain and range of the function in interval notation. Okay, and that's where smallest to biggest also comes in. So I'm going to zoom in. So our domain is the x value. So this is the leftmost x value, and here's the rightmost x value. Now, to determine parentheses or brackets, you determine if the line is filled in there or not. So at -4, since it's a closed circle, that would get a bracket. And at x is 2, it's an open circle, so that would get a parenthesis. Your range is smallest to biggest, smallest to biggest. And then the smallest value has an open circle, so it gets a parenthesis. And your largest y value has a closed circle, so it gets a bracket. This would be domain and range of this particular function. Okay. Example 2, write the domain and range of the function in interval notation. So the domain is the leftmost x value to the rightmost x value. Okay. And again, at -2, it's a bracket because the circle or the function is closed there. You don't have to pick up your pencil, you can fill it in. And at the rightmost endpoint, it's at x is 3. There's an open circle there. The point doesn't actually exist there. It just goes up to it. So that's where you get the parenthesis. The reason I wanted to talk about this problem is the range for this problem is a little bit tricky. Range goes bottom to top. So the lowest y value is actually here at -5. Okay, and since the line is filled in there, there's not an open circle, you don't have to pick up your pencil, this would get a bracket. And then the highest y value is 4. There's also a closed circle there, so that would get a bracket as well. If you had said the lowest y value is -1, there's all of these values that are lower than it. Okay, so read it bottom to top or smallest to biggest. Increasing and decreasing of a function. So increasing, as x gets bigger, y also gets bigger, and as decreasing, as x gets bigger, y gets smaller. To determine increasing and decreasing, read the graph from left to right. So an example, determine the intervals on which the function is increasing or decreasing. So you would start at the left side. We go down, this is decreasing, back up, increasing, flat is constant, going up is increasing, going down is decreasing. If I would have read the graph the opposite way, from the right to left, I would have gotten increasing, decreasing, constant, decreasing, increasing. It would have been completely backwards. So make sure that you're reading this from smallest to biggest or from left to right. The intervals on which the function is increasing, you look at what the function is in itself doing, and then your intervals are the corresponding x values. So for instance, this piece is where our function is decreasing, and it decreases from x is -6 to x is -4. So in interval notation, this is -6 to -4. I think Alex will accept brackets or parentheses. I will only use parentheses. If and when you get to calculus, you'll know a little bit more about why, or if you want to talk to me about that, I'm free to chat about that as well. So with example 1, determine the intervals on which the function is increasing and decreasing. You read this graph from left to right. So for instance, if I start at the left, it's going down, so it's decreasing, up is increasing, flat means that the function is constant, increasing, decreasing. If you would have read the graph from right to left, it would have been backwards. So for instance, you would have gone increasing, decreasing, constant, decreasing, increasing, which is not correct. Read it from left to right. Okay. So determine the intervals on which the function is increasing. So you look to see where your function is going up, and then your intervals are the x values that correspond to the function going up. So for instance, this piece right here is increasing, and it's increasing from x is -4 to -3. So this becomes -4, -3. If you want to talk about why I use parentheses, it has to do with calculus. I think Alex will accept either, but if you want to chat about that, let me know. And then the next piece that's increasing is right here, which is -1 to 3. To find where the function is decreasing, we do a similar process. We look where the function is going down, and it goes down from x is -6 to -4. And then your other interval, Alex might use commas, would be from 3 to 6. Thank you for watching. If you have any questions, please feel free to reach out to me.